The geometry of a parabola implies a very important reflective property that gives real-world meaning to the word focus. As the diagram of the parabolic reflector shows, lines from the focus reflect off the parabola along lines parallel to the axis of symmetry. This is how a flashlight works. Conversely, lines parallel to the axis of symmetry reflect off the parabola directly into the focus. This is how a satellite dish works. Example problem 3. Using parabolas to solve problems. A solar reflector. The parabolic solar reflector pictured has a depth of 2 feet at the center. How far from the vertex is the focus? Another way to ask this is, what is the focal length? So first let's consider, what is the shape of the solar reflector? Well, a cross section is part of a parabola and it's 8 feet across. In order to use what we know about parabolas to answer this question, we should first graph or represent this parabolic curve on a graph of a parabola with its vertex at the origin. And you can see that's done for us. Graph the parabola in a coordinate system with vertex at the origin. The vertical parabola has the form y equals 1 over 4c times x squared. Recall what we've learned earlier in this section. Substitute either the point -4, 2 or the point 4, 2. So what is meant by this is to find c, substitute one of our known points of the parabola, either -4, 2 or +4, 2, into the equation. Y equals 1 over 4c times x squared. And much of as we have done in the past, we can substitute in known values of x and y in order to solve for any other unknown variable, in this case c. The book has chosen to use +4 and +2. That would have been my choice as well, just so that we can avoid a possible error with negatives. If you have the choice to use all positive values, it's probably best that you do. So substituting in a y value of 2, we get 2 equals 1 over 4c times our x value of 4, and that will be squared. 4 squared, of course, is 16. We can cross-reduce here. As a matter of fact, we could have cross-reduced a little bit earlier and saved me a little bit of work. Note this 4 squared. One of those two 4's can cross-reduce or kind of cross-cancel with the 4 in the denominator, leading us to 2 equals 4 times 1 for a numerator, 4 over c. And seeing where this is going, we could multiply both sides of the equation by c, or just take an intuitive look at this and realize that, well, 4 divided by 2 is 2. So c, in this case, equals 2. Knowing c, as in problems in the past, allows us to easily identify the focus. And since our parabola is vertical, our focus will be, well, it will have an x value of 0, y value of 2, and our directrix will have the equation y equals -2. But recall we were asked to identify the focal length. How far from the vertex is the focus, or what is the focal length? Well, recall focal length is the distance from the vertex to the focus, which happens to also be the distance from the directrix to the vertex. But in any case, that value is 2, and since our units are feet, that would be 2 feet. So I can find room to write it here, or I can identify it here. And a chance to show that you have got it. The mirrored reflector of a flashlight is 8 centimeters across and 4 centimeters deep. How far from the vertex should the light bulb be positioned? Work carefully and make your selection from the choices below. In Chapter 4, you studied how to translate a parabola from one with a vertex at the origin to 1 with a vertex at the point hk. For such a translation, all of the other features, the axis of symmetry, the focus, and the directrix, translate along with the parabola and its vertex. And a great table to add to your notes. Key concept: transformations of a parabola. Well, notice with a vertical parabola, we have the equation, the focus, and the directrix shown here to be rows in the top of the table. If the vertex is at the origin, notice the equation of the parabola is y equals 1 over 4c times x squared, as we've seen several times in this section. The focus is at the point 0c, and the directrix is the line with the equation y equals negative c. Now, note, if we have a vertex hk, where h of course represents the x value of the vertex, and k the y value of the vertex, the equation of the parabola can be written in the form y equals 1 over 4c, it should look really familiar so far, times the quantity x minus h squared plus k. Take just a moment to consider what happens if h and k are 0 in this form. What you should notice is that the equation simplifies back to the equation we're used to working with when the vertex is at the origin. Notice what happens to the focus. The focus is at the point 0c when the vertex is at the origin. When the vertex is at the point hk, our focus is at the point h, k plus c. And finally, notice what happens to the directrix. Our directrix used to have the equation y equals negative c when our vertex was at the origin. Now it has the equation y equals k minus c. Now I won't walk through the bottom section, the ideas for a horizontal parabola. They're very similar and all things you should consider and add to your notes.